All right. Okay, so we know the mass is, all right, the total energy is, the amplitude is 0.84. That's joules. And that's kilograms. Okay, what distance is it when it's put? How are we going to do this? Oh, total energy. Okay, so I think what we're going to do, it seems like we're going to use this guy. Total energy is, we have to use this, right? They're telling us the total energy. We have to use the formula for total energy, but how? M omega squared x naught squared. Okay, so total energy is 16.8, and that is 1/2 times 4.20 times, oh, that's it. We're going to use this to find omega, aren't we? Okay. All right, so if I give you the total energy, we'll use that formula to find a missing thing, right? If you have no idea what to do, I kind of tell you what to do. Okay, so let's find omega here. So 16.8 times 2 divided by 4.2 divided by 0.84 squared is going to be omega squared. So omega squared is 11.337, right? And then raise that to the 0.5. I'm going to store that baby. Okay, so omega is actually 3.3671 radians per second. Let me just double check that I did that correctly. 16.8 times 2 divided by 4.2 divided by 0.4. Yeah, that's right. All right, so that's the first part, right? Now, what distance is it when it has a potential energy of 11.3? Oh, good golly. Oh. Okay, well, if the potential energy is 11.3, then if the total energy is kinetic energy plus potential energy, right? And the total energy is 16.8. And the kinetic energy we don't know, but the potential energy is 11.3. Then our kinetic energy must be 16.8 minus 11.3, 5.5 joules. That's something, right? Yes? Okay. So now we have omega, we have what the kinetic energy is, and now I think we can use the $1 million formula, right? It's 1/2 m omega squared. You poor kids. I'm setting the bar kind of high here. I think you can do it though. Just by golly, by gosh, you ought to be able to do it. All right, so we can just plug in 5.5 is 1/2. The mass is 4.2. Omega is 3.3671 squared. The amplitude is 0.84. And the distance from the equilibrium is what we want to find. Good golly. How on earth are we going to do that? Okay, well, I guess it's not square rooted, so it shouldn't be too bad. Okay, so 5.5, I'm going to go 5.5 times 2 divided by 4.2 divided by the answer that I got. So I'm actually recalling this from memory. This 3.3671. But I'm not typing that in. I'm actually using memory, and I got to square that. Okay, and now I've got what equals. I've got 0.231 equals 0.84 squared minus x squared. So I did this times 2 divided by this, and I've got this. Came out even. That's kind of cool. Who would think that would come out even? All right, and now I'm going to go this minus this, and I'll have negative that. So that minus 0.84 squared is negative 0.4746 is negative x squared. So let's go, parenthesis, the opposite of the answer, raised to the 0.5. And I'm getting that x is 0.6889121 meters, right? Or 0.689. All right, 3 steps. Step 1, we found omega, right? I told you the total energy formula, just set it up. There's something you don't know, find it, right? If I tell you potential energy, you've got to use the relationship. It's not in your data packet. I think you know it though, right? The total energy is kinetic plus potential, right? And then $1 million. I think we always use this one, right? That's why these are so hard.